Hi, this is Mr. Cook. This is for Chapter 7, Lesson 1, Example 1. If triangle ABC is similar to triangle RST, list all pairs of congruent angles and write a proportion that relates to the corresponding sides. Actually, we don't even need a picture for this. You can do this problem just by looking at the statement that triangle ABC is similar to triangle RST because the letters are listed in corresponding order. So let me just rewrite that statement here. So that means that A corresponds to R, B corresponds to S, and C corresponds to T. So I can list the angles in that order. Angle A should be congruent to angle R, and angle B should be congruent to angle S, and angle C is congruent to angle T. So there's the first part of the problem. So we just listed all pairs of congruent angles. Now we want to write a proportion that relates the corresponding sides. So in this case, if we take side AB and name the corresponding side to AB, again, you don't have to look at the picture. AB are the first two letters of the triangle name, and RS are the first two letters in the other triangles. Those two sides correspond to each other. So we could write AB over RS equals, and then do another pair of corresponding sides. This time we'll do the second two letters, so BC and ST. So BC is to ST, and then your final side is your first and last letter. So the first and last letter in triangle ABC is AC, and the first and last letter in the second triangle will be RT. If we had lengths for each of these sides, you would see that each of these fractions would just be multiples of each other. So they'd all be similar fractions. Hello, this is Mr. Cook. This example is for Chapter 7, Lesson 2, Example 2. We want to check in this example if the two triangles that we have are similar. And in order to do that, we're going to have to set up some proportions. So we're going to have to identify which side should be proportionate in the first triangle to the second triangle. Well, as you notice, we have two 90-degree triangles here. Angle Q and angle M are both 90 degrees, which makes our two legs here and here. We could just check the legs, and then we have the hypotenuse across from the right angle. So we should be able to easily identify these things. First of all, though, to help us do that, let's fill in our missing angle. I know I have a 90 and a 40 in each one. That makes my missing angle 50 because all three angles have to add up to 180. So I can throw that in. That'll just help me set up my ratios. So here I could let's look at the legs first. We'll look at the shorter leg in the first triangle, QR. QR should be proportional to, QR goes between the 90-degree angle and the 50-degree angle. The letters, or the side that goes between the 90 and the 50 in the triangle on the right is NM, so that one should be proportional. Now, if these triangles are similar, that means that we should have equivalent fractions here. So my next step is to set up a ratio of the other leg. So that would be QP and ML. Alright, and then finally my hypotenuse in each one, which is RP and LN. Alright, so now all I have to do is replace these names with the corresponding numbers on each triangle. QR is 7.5. NM is 8.6. That should be equal to QP, which is 8, over ML, which is 9.2. And my third fraction here is my third side, 11, which is my hypotenuse, over 12.6. Okay, now if these are similar triangles, these fractions should reduce to exactly the same fraction. However, in this example we have decimals, which means these sides were probably rounded off. So we're going to use our calculator here and actually just divide each one. 7.5 divided by 8.6 is approximately 0.9. And if I divide 8 by 9.2, I get 0.9. Now, again, I'm rounding these to the nearest tenth because most likely these numbers, the 7.5, the 8.6, the 9.2, and the 12.6, most likely those have been rounded off. And 11 divided by 12.6 is 0.9. So as you can see here, all three fractions are equal to the same decimal, 9/10, which means that these two triangles are similar. So I should write a similarity statement, putting the letters in their corresponding order. So the triangle on the left is, let's go with PQR, would be similar to triangle. P is 40 degrees, so that means I have to start with L, which is the 40-degree angle, then the 90-degree angle, M, and then N. PQR is similar to LMN. Hello, this is Mr. Cook. This example is for Chapter 7, Lesson 2, Example 3. Here we're using similar polygons and proportions to set up an equation and find some variables. I want to find what x and what y are. So this problem tells us that the two polygons are similar. ABCDE is similar to RSTUV. So if I look at my polygons, if I want to find x, I'm going to have to set up some ratios here. X is for side CD, that would correspond to side TU. So I could set up for my first equation x over 3 because CD is similar to TU. And then for my second fraction, I need to set up just one other fraction here, but it has to be two sides, one side in each of the polygons that I know that I have the answer for both. So I don't want any variables in it. And if you look here, our key is AB and RS. Notice there's two numbers on there, and those are corresponding sides. So in my first fraction, my first ratio, I chose x, which is in the bottom polygon first. So that means when I set up my second fraction, I'm going to have to choose AB, which is 6 first, and then on the bottom 4. Now all I have to do is solve that, and I can figure out what x is. Well, if you were paying attention in 7-1, you'd know that all we do here is we cross multiply, so that gives me 4x equals, and then 3 times 6 is 18. And then all I have to do is divide both sides by 4. And that gives me the answer, x is equal to 4.5. Okay, now let's set up the same thing for y. I can use the same two sides. I can use this AB and RS to help set up my ratio. Except this time I need to find y, which means I'm going to use y plus 1, and the side that's similar to that would be ED, so that would be 8. So I'm going to use those four sides there to set up my proportions. So let me set up the first one. I'm going to say y plus 1, so I chose from the first, or the top polygon, and then from the bottom polygon is 8, and I set that equal to. Now this time, because I chose from this polygon first, I'm going to have to choose the 4 first before the 6. I have to remain consistent with how I set up my ratios. That would be 4, which is the smaller polygon, over the larger polygon, which is 6. Now this is the same process. I just cross multiply and divide. But when I cross multiply this one, I'm going to have to distribute the 6. So I end up with 6y plus 6 equals, and then when I cross multiply this way, 8 times 4 is 32. I am going to subtract 6 on both sides, and I will get 6y equals 26, and divide both sides by 6, and I get 4.3 repeating. So we'll change that to an approximately 4.3, or 4 1/3 if you want an exact answer. Hello, this is Mr. Cook. This video is for example 4 in lesson 7.2. If ABCDE is similar to RSTUV, find the scale factor of ABCDE to RSTUV and the perimeter of each polygon. So first thing we need to do is find the scale factor. Scale factor simply means that we need to find out what we have to multiply by to go from one polygon to the other. So for example, if I want to find out what I have to multiply each side by in ABCDE to get RS or RSTUV. Okay, so in order to do that, I need to set up a ratio of similar sides. So what I look at when I notice ABCDE is I have several pieces that are congruent. So notice here you have these two sides are both equal to 4, and similarly in the polygon on the right, these two sides are both equal to 7. So this is a 4 here and there's a 7. Well, according to the name ABCDE, AE, which is the first and last letter in the name, should be similar to RV. So that means this side should be similar to this side. I can use the numbers from those sides, the 4 and 7, to figure out what my scale factor is. I'll simply set up 7 divided by 4. And that's going to tell me what I have to multiply 4 by to get a 7. 7 divided by 4, if you throw that in your calculator, is 1.75. So that's my scale factor, is 1.75. So that means I can multiply everything in the smaller pentagon to get the numbers in the larger pentagon. So in order to do that, in order to find the perimeter, I'm going to have to do that with all of the sides. So I have to figure out what these sides are. So right now I know that RV and VU are both 7. So that's simple. And I know that this is 10.5, which means that the other side is also 10.5 because it has 2 marks on it. Now I need to find what ST is. Well, ST should be similar to BC. BC is 6. So what I want to do here is I want to take 6 and I want to multiply it by 1.75, and that should give me my answer. So 6 times 1.75 is 10.5. Which means that probably this side should have two marks on it as well, which makes that the same. So if those are 6, that makes this 6 and 6 as well. So now I can find the perimeter of each one. The perimeter of A, B, C, D, E would just be all of the sides added up. So I've got 3 6s, that's 18, plus another 8 there would give me 26. So the perimeter here is 26, just all those sides added up. And the perimeter here would be 10.5 times 3 plus 14 for the top 2 7s there, which would give me 45.5. So my perimeter is 45.5 for the large RSTUV, and the perimeter for ABCDE is 26. Now, actually, another way you could do that, since we found the perimeter for RSTUV first as 45.5, I could divide that by 1.7 if I wanted to go the other way, and I would get 26 there as well. Or in other words, 26 times 1.75 is 45.5. So if you find this, so this works with the perimeter as well, the scale factor. So we've got 26 and 45.5.